Good afternoon and welcome to my presentation about Class A SMC and the future business, especially in automotive and also in high surface quality applications. So for those, they may know our company Aliancys. We are formerly known as DSM Composite Resins, and many people from you may know this company. And since last year, 2016, January, we are with Aliancys. And this is a new company which is a joint venture between DSM and CVC. So our product portfolio is basically in many different segments, and in the segments we are, for example, in the marine industry, we are in automotive industry, industrial applications, as well as pultrusion applications offshore. So wherever you have composites, you can find us back. So where are we located and how is our company organized? So we are currently in Europe with three different production sites in France. There is one other production site in the Netherlands and one in Italy. Beside these three, we have a production in China, which is supposed to be the biggest in the world with about 100 kilotons of capacity. Beside this production site, we have also R&D centers. One R&D center is located in the Netherlands, in Zwolle, and one other is located in China. And these two R&D centers, they are mainly on resins and development of new resins for new applications. And in addition to that, we have one R&D center for sizing and binders on glass fibers or any other fiber. Because there is a combination of the two products. You have the matrix system and you have the glass fiber as a reinforcement or any other fiber. And you need a good bonding. And the good bonding just is possible by adding the right sizing on a fiber. So we have also this technology in-house. Going into this, what we do, as you can see here, the quality resins are already known in many applications for many years, more than 50 years, with the heritage of DSM and also the professional delivery of resins in a very narrow range of specification. Now coming to the major part of the presentation, which is about SMC Class A. Class A means top surface quality, premium for automotive industry, for many other applications wherever good quality is required. So as you can see here, this technology of SMC, BMC is already well established in the market. It's already there for about 50 years, you can say. We just invest in this new line in our R&D center in order to be able to do direct developments with our customers, with our clients, to improve and to get better in quality and to develop new products for new markets. Especially when you think about transportation industry, everybody is thinking about electrical vehicles. A new generation for sure will come, and then weight is one of the most important issues that needs to be solved. For example, in the heavy-duty truck industry, also in the light truck industry, composites are, you cannot live without. So this is the message. You need composites in order to reduce weight, because weight on the road is just waste of money first, and all the big players, they want to integrate material which enables them to reduce weight. So SMC, as I said, is already known in body panels, in many, many panels. I can show you here. For example, the grille, the bumper, the side skirts, even the sleeper or the air deflector is something you can do easily in a truck. But not only the visual parts, but also structural parts can be, let's say, used or can be made out of a composite material instead of steel. So truck industry is one approach. New approach is also into high-end cars. High-end cars, they require an excellent surface. So everybody knows if you look at a high-end car and you spend hell of money, you want to have a good product, a good surface image, and this is what we can do. For this car, we are already in with the trunk lid, with this element. Here, it's the part you can see from the outside, but also the inner structure is made of carbon fiber SMC. We developed already many years back, but now it's the time to market it and to launch it to the industry. And here we have also the right products. If you look further, what is the key? And the key message is here, you need a good surface image. Which is, let's say, similar to the same quality you know from metal, from steel. But it's simply too heavy. So this is basically the approach why we are concentrating on SMC for automotive and transportation industry so much. And we as Aliancys, we have a good history with the big players. We have a really strong position to all OEMs, whatever you name it, if it is Mercedes, if it is BMW, if it is Volkswagen or so, they are all in contact with us. So, then you would ask why SMC for these applications? They have many advantages compared to other material which are used in automotive. For example, with SMC you have excellent design freedom. Nowadays, density and lightweight is a very important parameter to look at. For example, 1.8 is the normal density of an SMC, ordinary SMC. Class A, but meanwhile we can achieve even 1.2. 1.2 density is pretty low, and if you go into a lightweight material, you can expect also a somewhat lower surface typically. But in this case, the Class A surface will remain. So this is what the market can already deliver. In the SMC for Class A, you have two elements. You have two applications. One is for the single shell, where no ribs are integrated in the panels. So that means you have a really flat panel. In truck industry, in many cases, they ask for ribbed panels in order to save some extra weight. And they have the surface, and right behind you find a rib, and this rib should be not visible to the or after the painting process. So both is possible. The surface structure is a very important parameter, very smooth, because everything which is, let's say, deviating from the surface, you see with your visual eyes right away. And this is what we are going to prevent. So there are electrical properties, especially when you go into a deck lid, where all antennas are installed meanwhile. So this is also another big benefit, because if you have a steel deck lid, then you see, or the radiation from for the radio system, they will not come through. So you need a composite material, and that will also at the same time resist to a certain temperature. So you also can integrate functions by adding inserts, metal pieces. And what is one of the most important parameters is also the coefficient of thermal expansion. Because every single material you use in a car has a certain expansion when you apply a temperature. So this is a very important parameter, and come later to this. So cost, of course, is another story. You have to consider cost. Everybody is comparing then with steel typically, and steel, to be honest, cannot be beaten if the number of series is extremely high. So, but nowadays with all the new cars, with the new electrical vehicles, you have different design, different components, and that means the number of parts to be produced on a yearly basis is between 500,000, maybe 500 and 100,000 parts a year. So that's something where we play. So whenever you are in a range of 200,000, let's say 100,000 parts, 150,000 parts, you are in a range where you can play with SMC very well and you can compete. As I said before, shrinkage is a very important parameter. We have a material, SMC, which intrinsically have a shrinkage. And we have to compensate this shrinkage. How to do that? So basically, we have different components. There's a base resin with a certain shrinkage, and we have to compensate this shrinkage. We can compensate it by using so-called low-profile additives, LPA. And these LPAs, they consist of polystyrene, PVAC, which is a thermoplastic solution, or PMMA is also a thermoplastic solution. But moreover, for better surface quality, you would start to use the saturated polyester. This is the highest performance you can get for the time being. Or something in between, and then we do kind of a mix, or we have products we called modified saturated polyesters. And then we come to a segment where we can use this exactly. So you see, typically per definition, you have shrinkage in a standard material where there's no LPA used. You have a shrinkage of about 0.4%, 0.5% in linear shrinkage, because the part has to fit somewhere. That's very important. So most people, they ask for a shrinkage compensation to come to the zero, or to have even expansion. So the part later on will be bigger than, let's say, the cold cavity. So that means it will smoothen the surface. And we have these kind of systems in place. Meanwhile, or already for long, these kind of systems like Class A or premium Class A is used in automotive industry. And what are we going to do basically with these LPAs inside? We impact the morphology of the material. So we try to gain volume. And if you look at the microscopic picture, this is what is behind. So it's a kind of a structure where you see some tiny balls, but the surface, and you have some pressure from the inside, which is inside a cavity, and then it will smoothen the surface. If you don't have this pressure from the inside, it will not deliver a good quality at the end. So this is about shrinkage compensation, and we have these products. I will come later to the products you can use in order to get there. The second parameter is, we talked about density. So I said, this is a standard density, which is typically used, about 1.85. Then you see a typical formulation for Class A, which consists of resin, additives, low-profile additives are already in, peroxide. You have also the filler component, which is a solid material which cannot shrink intrinsically. So this is the major part with about 47%. And about 28 or 25% is basically glass. And the cheapest raw material used is, let's say here, the calcium carbonate filler. And you can play with this. So if you go into a density, for example, for 1.35 or even lower, the only way is to do it with hollow spheres, glass hollow spheres, for example. Everybody knows, I would assume. And you see here, the amount of resin will remain the same. There you go, filler. And the 6% is the lightweight filler. So you replace standard filler, which is typically 47 to the 28. And you have to increase then the fiber content in order to have the same mechanical performance. So this is how a typical low density formulation would look like. Of course, there are more details, but this is, let's say, a starting position. And if you have an interest to go into this segment, into low density, we are ready to start doing business with you and to support you to reach this level. As I said before, we are competing with other materials in that industry. So we are competing with steel, we are competing with aluminum. And SMC is, let's say, the material of choice already for long. The new generation goes into carbon fiber, but with carbon fiber, so far, we cannot reach Class A surface. So I have to be honest here. That's not doable. But carbon fiber, honestly speaking, is a product you want to use in places where you need strength and low weight. And this is typically more a structural part or a semi-structural part. So if you look, for example, to the properties, I have listed it here, and the potential of the lightweight. You see here the density of 7.8 for the steel and aluminum also with 2.7, but we are somewhere here with 1.8. And if you go to the lower viscosity I mentioned already, 1.2, you are even getting better. So these are the properties you can achieve. But if you go into a molded part, you have to consider the specific properties. That means specific tensile strengths and specific modulus. This is basically a calculation of the part thickness, the density, and the performance of the material in strength and modulus. And if you see here, for example, if you take this in calculation, the specific strength of the steel is 4.6. And with SMC you reach 4.5. Another parameter I had in my list before is the coefficient of thermal expansion. That means every material you use expand while you add some temperature on top. I also list here a few products which are typically used in automotive industry. You see polyamide, nylon. A typical type is PA66. Yeah, when you put some temperature on top, so it will expand a lot. You see here, the number is extremely high. Other products, when you add some glass fiber, it's already getting better with polyamide, but still more expansion. If you then look at these products here, steel, SMC, BMC, and so on, they have the same, let's say, thermal expansion coefficient than steel, which means all these gaps here between the trunklet and the fender, for example, they will remain the same in the summer period as well as in the winter period. So if you use other materials, yeah, in the summer period it's very narrow, in the winter period you have a wider gap, which is, I think, one good argument to go and to use SMC. So now, as I said, I will go into these products, what Aliancys portfolio is offering to that industry, and we have new products developed. Just to give you a short overview, it's not all what we have, but these are the typical products you use for Class A and premium surface applications. As I said before, base resin is needed, and these types, they are all used in Class A. That means our Palaprec, this is the brand name, P1803 is already known for decades in the industry, even the Palaprec P04302. And now this Beyond is, let's say, a new brand name of us, of Aliancys. This 181 is also a product suitable, and it just closed the gap between the two products we have here. So you can use it in between. So, but these products, they have a shrinkage, and you need to compensate. And the compensation can only be done by adding an LPA and low profile additives that are typically used, especially for Class A, premium surface. These are the followings. So you see here Palaprec H1080, it's a PVAC solution. And then we have the better types, as I said before, when I showed the performance of shrinkage. We have this H892, which is a saturated polyester. What is important to know for these products, they have a certain viscosity. And as lower the viscosity, basically as better it is to add filler and to operate on SMC line. So this product, for example, Palaprec H892 has a low viscosity of about 150 millipascal seconds. It's extremely low. Compared to this PVAC solution on the top, you have a viscosity of approximately 4,000. So it's huge difference. 2681 is also a saturated polyester, and this saturated polyester goes into the premium segment. The pictures you have seen before, for example, this trunk lid or hood or fenders or even truck panels, this 2681 is, let's say, the major low profile additive to be used. Palaprec H2700 is a new development. I will come later to this because I have much more details about it at the end of the presentation. The other Palaprec H852 is also a modified saturated polyester, which is extremely low viscous, like the one above, the H892. So we are also in the field of 150 millipascal seconds. And then we have another modified saturated polyester for specific applications, and a new development, which is called Beyond 875. It's also a PVAC, like the one above. The big difference is you have similar performance, but the viscosity is about 300, while the other one is 4,000 or 4,500. And the solids content of the product is basically the same. That means it gives better performance on the manufacturing process on the SMC line. With my next slides, actually I want to demonstrate where these products are used, because we have a case history for all this. And you may know these cars and parts I will show you immediately. So for example, if you use this base resin I just mentioned, P1803, this is a specific pure maleic resin which is excellent and easy to operate, really easy to operate. So our clients and compounders we are working with, they really appreciate this product. By adding these components, these are basically the products you have to mix in a way to get the best performance. Either you do it with this H892, just two products, or you do this product plus this and this. Then you can go into a segment like a trunk lid or like a hood or whatever. The H875 is basically a product for truck applications. Already well known. And as you see here, for the other panels, this is the Volkswagen EOS. The trunk lid is made of this P18, as well as this Megane from Renault. I have other pictures to show, but this is just the most famous ones you may know. If you go into a premium segment also, and some players, they are convinced by using this Palabrec 0423 in combination with 2681, this shrinkage compensation to get the smooth surface. You find that back in trunk lids like Mercedes, like BMW 7 Series. They use this. They are happy because in the trunk lid, there are all antennas installed. Even in the BMW. Not in this model, but in the 7 Series, you cannot find any antenna here. So they have it integrated in the trunk. With all these positive results. In the truck industry, it's basically used because a combination of 0423, Palabrec, and 2681, you have excellent performance above a rib. Because typically when you have a rib inside, you see some sink marks after molding. And by using this is almost eliminated. You cannot see it. You cannot see the rib anymore. And therefore, if you go, for example, for a bumper where you have ribs behind, you need a stiff element. This one is excellent in performance, and you cannot see it from the front. There are ribs behind. As I said before, we have a new development which is called Bion 818. This product is bridging the gap between the two products, Palabrec P18 and our P0423. So it's also for a wide range of applications, and we are much closer now to, closer to our customers and the compounders. They have now more freedom to play. Here, I give you also the example, because 2681 is the low profile additive, the best choice for rib panels. I just mentioned it before. This is a bumper, and there are the ribs behind and bosses. And this is at the end not any more visible. This is something really, really positive. And if you want to achieve this, the best choice is to start working with these materials in combination. The other low profile additive on the list was our Palabrec H892. This is basically for flat panels where you don't have ribs, so we have excellent performance. But if there is no chance and you need this same product because of logistics or whatever, if you add some cobalt accelerator, then you can boost the performance, and you have also good performance above a rib. So this is the message here. It's also excellent product and excellent performance, not only in compression molding, but also in injection molding. And by using these two components, for example, you can expect a high gloss, really glossy surface. If the mold is good, you see also excellent result after the molding with a good glossy surface. Other parts you can look at, now we are coming to PVAC solution, for example. two different components. One is the higher viscosity. It's, let's say, the one which was developed many, many years back. And the new generation is H875, which gives you a viscosity of approximately 300. Compared to this, about 4,500. So you're more than 15 times lower, which enables you to play around with your formulation, to add more filler, to lower the cost on the formulation. Parts you can consider are in the agriculture industry. In the agriculture industry, for example, but also in the automotive industry, people use it. H852, the modified saturated polyesters, they are also well known in the truck industry, but also in the agriculture industry. You see panels over there. They're huge. Because this H852 is a product you can also use in low pressure applications. Sometimes the molding force on a press is not sufficient, because typically you need 100 bars inside a cavity to mold a part. But if you have a big one, sometimes the capacity of the mold is not sufficient. So it's basically better to develop then a system which is low pressure. And this H852 can be used in low pressure systems. And when I talk about low pressure, I mean 30 bars. About 30 bars instead of 100. But to be honest, if you go slightly higher, it will generate a better result. If you go 35, 40, that should be suitable. Beside the Class A, I want to give also just brief insight on other products and other developments we do. We are not only in Class A, but we are also in structural parts already for many, many years. If you look at these two products, this is a vinyl ester-based product. It's our brand name Adlac XP810. This product is extremely resistant to all media you can find around the motor, the engine of a car. So that's why this product is also used for oil sump or for rocker cover or any element which is close to the motor. Because in that area you have spray water, salt water, you have brake fluid, you have cleaning water. All these kind of elements, they impact this. And even oil. And oil can be also aggressive. So we've tested this, and the material is suitable. And for many years, it's already used in different trucks for heavy-duty trucks. And temperature resistant is also excellent, because everybody knows the temperature of oil within a car or within a truck can reach easily 90 degrees C. So, and this temperature will resist, no issues. So we have a lot of experience from the field, and this is still running. A new generation we developed, because that's already many, many years in progress. That we developed also a new product which is called Beyond 819. This Beyond 819 is a low viscous vinyl ester resin, similar to the XP810, a bit modified, but the difference between the two is the top one has a viscosity of 2,500 approximately, but this one is below 1,000, which is also gives a positive behavior in filling by adding calcium carbonate or aluminum trihydride. So it's a new development, low viscous, and demonstrates excellent performance in the mechanics, similar to this XP810. So we are now going into that, and we are launching right now this product to the industry. What you can do with these products, I give just two examples. As I said before, this is already in the industry for many years. example, this is from Scania, no, from Volvo. From Volvo, they have this green color. And for example, the Renault trucks, they use the rocker covers based on our vinyl ester resin, which resists all the material you can find back under the bonnet. I also want to give you a brief about BMC, because BMC is the other application of a big interest in the industry. Many people, they use BMC for the headlamps, but you can also use for a throttle box, for any other panel around the motor, an engine. Depending on the performance, you have to choose the right resin. But I give just one example for headlamps, because the main focus of the presentation is about surface. P18 is the well-known product in headlamp applications. And H852, this modified Sanayicileri polyester, is the combination to this in headlamps. I just pointed out here how a formulation could look like. It's basically a mix of the two products, that you have a kind of a feeling how does it look. You have then the peroxide. You have, and you need this for sure, big additives to lower the surface tension and to have a better wetting behavior of the material during the processing. And even more, you have an excellent surface finish. So they impact also the surface a lot. So this is typical formulation you can look at. At the end, everything is dependent on your process. The process is so important that you have a good quality control on that. That mixing behavior on a set plate kneader or on a turbo mixer is considerably the same for every batch. So batch-to-batch consistency is for the automotive industry, as we learned, the major key. And the automotive industry, for all the products I mentioned before, P18, H852, they audit us. And they came and said, you can do a much more narrow specification because you can deliver a product which can do it, because you demonstrate already. And this is what we did. So we narrowed down the specifications even in the products, which enables us to deliver products to our clients which are in a very narrow range of specification, and the batch-to-batch consistency is really important, and we can deliver that. As I said, there is one more product, this Palabrec H2700, that is also a recent development we did. So also the smell is lower, and the processing is easier. That's what we heard and we received from our customers and compounders. They confirmed this. Giving you a few numbers about it. By using that material in a Class A standard application, for example, we made a direct comparison in our lab on a press equipment. We are able to produce SMC, and we can also mold the SMC. We look at it, and you see here, by using the 2700 in the formulation, you can increase the strength, the flexural strength, for example, for of about 25%. Even the outer fiber strength is higher than the standard. Flexural modulus, so if you have impact on the mechanics, then of course the modulus is also impacted, and the impact strength is also slightly higher. If you take this into consideration and you look at the and you bring it into a real part, you are able to reduce, for example, thickness. And by reducing the thickness by 0.2 of a millimeter, you have again a weight saving of about 8%. And that's key for industry. So the density is basically similar. And the weight basically is then lower. So all in all, there's a cost saving. What we also did find is you have better release performance. That's also visible here. So we did find other advantages. So we checked the VOC and the FOG, and we could find lower values compared to a standard Class A system. At the same time, we have to say by coincidence, we also did find a better release performance on the mold. So you can use less stearates, less release agent, which gives another benefit in cost. Or you go with the old one, but you have better release performance. So all in all, a product, to our opinion, which combines a lot of functions and delivers excellent performance. Before I go to the another new development and the future, I will stress here about the Class A applications in composites. We believe Aliancys, as Aliancys, we have the right resins in place for all these applications. They are broadly used in body panels. The industry, they believe in us. That's what we can see. In public transport, in truck applications, in mass transport, wherever you see it, our products are in place. You name it, it's for standard applications, but also for fire retardant applications. You can achieve this good surface. By using the right LPAs, you are in the best performance. Yeah, and our customers, as I said, they really appreciate this performance and the new developments we do. This is the last part of my presentation, and I want to stress a little bit on the future business. And future business nowadays is weight saving. So, and we have to try to push the limits a little bit in the industry. It's not only about the capabilities to produce it, but we invest in a new SMC line in our lab just to do this, in order to be ready to make the next step and to follow the generation to come. So we have this full range, we have the capabilities, and the new generation is, as I said, carbon fiber. And carbon fiber is, you cannot use on an ordinary SMC line, I have to say. This is not doable because of different arguments. If you are interested in that, we can discuss on that, because it took a while to get there, to have the machine ready to perform these kind of materials. Our new generation in resins for carbon application is Daron. Daron is a brand name we have already for a while, but we have now new products. They bring excellent performance in this segment. We reach already extremely high performance, and I will show you briefly where we are now. This is also part of the SMC line we have in place. So whenever there is a potential or already existing customer, we can use this together in order to improve and to get to the next level. What we already achieved, and I want to give you just a brief. What we already achieved in performance by using carbon fiber is the following. And we're competing also with epoxy here, we know, and steel. But where we are is we achieved already a flexural strength of about 500 megapascal. We achieved modulus in flexural strength about 32, and a tensile modulus about almost 40, which is, let's say, above the epoxy resin at the moment. They also deliver SMC, but this is exactly a high value, and values the automotive industry is asking us to be. This is basically really close to the target and what the automotive industry is aiming for. So what we also see is excellent performance because it can be molded like ordinary SMC. You have the same flow. And we also test, of course, the shelf life of a compound. And what we found out is you can store the material for 60 days or even longer, and you can mold it. So that means the stability of a product using this Darwin technology is excellent. Here you see a few parts made of carbon composite. This is the inner part of the deck lid, and it's chop strength carbon fiber. Meanwhile, the automotive industry is also asking for this to strengthen the product wherever it's needed. Not all over, to have the very expensive material, but only at the spots where you need to reinforce, it has to be reinforced. And by doing this technology, we can also put elements inside. For example, this is SMC based on glass fiber, the light color. And this is a UG SMC, unidirectional or fabric, with carbon fiber. So you can, and both are impregnated. So both products are impregnated, and after the molding process, it looked like that. If you have 2 minutes, I will show you a brief video how it goes. I'll make a little step. Oops, it's not working. My computer, it's working, but not there. Excuse me, can you? I have here a video, but it's not working here.
Because it's accented.
Oh, here. Okay, so. Okay, then go back. Yeah, can I? Oh, here. Yeah.
Sound.
No sound. So what you see here is the cutting of the carbon fiber pre-crack we produce based on our Darwin resin. Then after some time, you can, after maturation time, you prepare, you stack some material and you prepare a preform. We call that a preform. This is just a test tool. Can be also automized, but for us, for the time being, you see we place the reinforcement before, and then we fix it. So we prepare a preform. And we are doing that, taking it out, and then it's fixed, and you can store it because it's, you see, it keeps the, it takes the shape and it stays in shape. This is, in this particular case, they cut carbon fiber, but we are molding also glass fiber. So what you basically do is you put the preform into the mold and you put SMC on top. Yeah, thanks. Yeah. So the molding process finished. And you see here once again from sidewise how we do it. In this particular case, it was 100% covered. It's not needed. You can also do it smaller. And after the molding process, you have a part with dedicated reinforcement elements and material which is a little bit lower in cost. with glass fiber based, because carbon fiber for the time being has a certain price and it's really expensive. Can you just use it, bring it back? Yeah, okay. Yeah, thanks. So this is the latest development what we did. We are focusing further because automotive industry, they require high strength, low weight. Everybody's investing into this. So we have to combine the best performance with the right products in place. And we believe we do have it. Of course, we cannot do it alone. We need also our partners, our customers. They want to go into this industry as a joint activity. Whenever you have questions, please come. And that's why our slogan is, let's talk.